Hi everyone, welcome back. Today we're going to continue with 10.6 polar equations. Today we're going to be using symmetry to help us graph. So our essential question is, how can I use symmetry rules to help graph polar equations? So yesterday you might remember that we drew a polar graph that ended up being a circle that just revolved itself around itself 2 times. And obviously circles have symmetry with themselves, and we could have used symmetry to cut down on the amount of, that super long table that we had yesterday. So yesterday I had us working from all the way from 0 to 2 pi. Today we're going to see, hey, maybe we don't have to do all of that. We might be able to cut back on all of the table and points that we use. Okay? So in order to actually use our symmetry rules, we have to know how many rules are there and what exactly do I need before I can use them. Okay, so it's going to be really important that you copy down at least this highlighted part, which tells you all of the rules for testing for symmetry. However, I would also encourage you to draw in these parts right here, because we need to really understand what do we mean by symmetry with the line theta equals pi over 2, symmetry with the polar axis, and symmetry with the pole. So as you write it down, I'm going to go ahead and explain and leave this up for just a little bit. So, as you guys know, we've been labeling our polar axes with 0, pi over 2, pi, and 3 pi over 2. If we're going to be symmetric to the pi over 2 line, it's basically similar to being symmetric with the y-axis. So we're going to be flipping whatever points we have on this side over to this side, and vice versa. So just flipping it across, pi over 2. Over here, symmetry with respect to the polar axis. The main polar axis is always this 0 line. So you can think of it as reflecting over the x-axis. Okay, so it's just going to be flipping over like that. Okay, the last one, a little bit tricky. Symmetry with respect to the pole. Now, how do we know what the pole is? It's typically determined by either theta or r. Okay, or both r and theta. When we have both of those values, we might have just some coordinate point out in space with a line connecting to it from the origin. If we're being symmetric to that pole, then we're going to go 180 degrees in the other direction. Okay, so 180 degrees this way. And then if we were over here, then 180 degrees that way. Okay? So that's the idea, that we want to be able to use these rules of symmetry to help us essentially graph a lot quicker, because yesterday's would have required a lot of time had I not basically provided you with all of the coordinate points. Okay, so we're going to go ahead and do one example, which means we won't really get to see how all of the symmetry works. We will be testing all of them, and you should test all of them just to make sure, hey, could there be more than one symmetry? Okay, so the first one I'm going to test with this graph. So we're going to be sketching r equals 3 plus 2 cosine theta. We're going to see if there's going to be any symmetry with respect to theta equals pi over 2. Remember that, kind of like imaginary y-axis. So in order to do that, what they're telling me to do is I need to replace any r's and any thetas with either, r is going to be replaced by r, and theta is going to be replaced by pi minus theta. If you don't want to use pi minus theta because you're like, wait, I don't want to do extra math, you can plug in this one. It's a little more simple, except you're going to work with negative pi and you're going to work with negative theta. Okay. Now, how do I know if it's going to be symmetrical? It's if it comes out with an equivalent equation. In other words, an identical equation. Okay. I'm going to go ahead and go with the negative r and negative theta. So plug in negative r, negative theta for r theta. Okay, so let's do that. Plug in negative r. I get 3 plus 2 cosine of negative theta. Now this does take us back to the trig unit. We do need to remember that cosine of negative theta still comes out as positive cosine theta. Negative r, of course, is going to stay negative r. So what we have is negative r equals 3 plus 2 cosine theta. If you need to remind yourself that, make sure to look back into the trig chapters. Because basically what we're saying here is if we go in the negative direction of a certain degree, we're going to still get the same exact value. Okay? So negative r equals 3 plus 2 cosine theta. That does not match up with our original. So we do not have symmetry here. So, nope. Alright, so we're going to continue on. Maybe we'll have luck with other ones. So 2, let's check if we have symmetry with the polar axis. Okay, so I'm going to go ahead, plug in. Let's see, r equals, for the polar axis, sorry. We are replacing with r negative theta. Okay, so r stays positive. I'm going to plug in. I get 3 plus 2 cosine of negative theta. That ends up giving me r equals 3 plus 2 cosine theta. That's the exact same equation as we had originally. So yes, we do have symmetry here. And finally, the last one to check is if we have symmetry with respect to the pole. And with that one, we're going to replace it with negative r theta. Okay, so negative r equals 3 plus 2 cosine theta. Well, I have nothing left to simplify there, and I'm left with a negative r. So these two are not equivalent to each other. So, nope. Okay, so the only one that we're going to have symmetry with is the polar axis. So that helps us cut down at least our work at least in half. Because now I don't need to do it from 0 to 2 pi. I can just do it from 0 to 5. Okay, so let's go ahead and try it. Doing the same exact thing we did yesterday. 0, r, 0, pi over 6, pi over 3, and pi. Okay? So we're going to check. Hey, will this be enough to help us graph it? You might have to test some more sometimes because who knows, maybe that curve lingers up in that first quadrant for a good while before it ends up being reflected over. So we're going to start off with 0 to pi. Just know that maybe this doesn't always work. Maybe you have to test a little more. Maybe you have to test a little less. Okay? Our whole point, though, is to try to cut things off. All right? So let's go ahead and plug in 0. So 3 plus 2 cosine of 0. Cosine of 0 is 1. So 3 plus 2 will be 5. Okay. Pi over 6, I'm going to get cosine of pi over 6 will be the square root of 3 over 2. 2 times the square root of 3 over 2 is square root of 3. So I have 3 plus radical 3. Okay, moving right along. Cosine of pi over 3 is 1 half. 1 half times 2 is 1. 1 plus 3 is 4. Pi over 2, that's 0. So we get 3. 2 pi over 3, we're going backwards now. So cosine of 2 pi over 3 will be negative 1 half. And then negative 1 half times 2 will be negative 1. So 3 minus 1, 2. 5 pi over 6, that's going to be negative radical 3 if I'm following the pattern correctly. That's going to be 3 minus radical 3. Finally, pi. Cosine of pi is negative 1. Negative 1 times 2 is negative 2. So I have a positive 1. Okay. I think that might be enough. Let's go ahead and see. Hopefully it is. So this one's going to be pretty big because we're going all the way to 5. Here we go. Let's set up our polar. There's 1. 2. 3. 4. And just to check how many of you are actually listening, go ahead and go to the comment section, maybe now, after the video, whenever you like. Tell us what you're doing for Memorial Day weekend. Hopefully you're not just studying. Here we go, our fifth circle. Okay, there we go. So, of course, it's not the best circles. I apologize for that. But we'll work with what we got. Alright? So, here we go. We're going to go from 0 degrees outwards to 5. So, 1, 2, 3, 4, 5. Then at pi over 6, we're going to go 3 plus radical 3. Radical 3 is about 1.7, so I'm going to go to 4.7, but I forgot. I insert these ever so special degrees. Okay, and if you're someone that hates doing all this again and again, feel free to print them. There are plenty of free polar grids online. You're just going to have to provide them for yourself. Alright, there we go. So we have 0, 5, 3 plus radical 3, so about 4.7 on pi over 6, so 1, 2, 3, 4, 4.7. At pi over 3, I'm going out to 4. 1, 2, 3, 4. Pi over 2, I'm going to 3. 2, pi over 3, I'm going to 2. So, right there. Nice and easy. 5 pi over 6, 3 minus radical 3. Okay, so that's 3 minus 1.7. That's about 1.3. Okay. So 5 pi over 6, we're going out 1 and 1.3. And then finally at pi, we are back at 1. Okay. Now, we're going to use symmetry to our advantage rather than making a whole other table with a bunch of values. We're going to go ahead and use our symmetry with the polar axis. Okay. So symmetry being with respect to this guy right here. We're going to go ahead and reflect all these points. This one stays where it is. This one will jump right down here. This one. That one's at 2, so this one should also be at 2. This one should be at 3, so we're jumping down to 3. Here we are at 4, so it's a little messy here. 4. Then we have this one. My circle's not exactly the best, but it should approximately be there. And boom, what we have is this shape. So connecting from 0, going sequentially. In other words, in the correct order, from increasing radians. Then we'll connect them down here. And with that, we've got a funky little looking shape called cardioid. Okay, so kind of looks like a heart, vaguely. It's got a little indentation right there, not exactly a smooth circle, so that's exactly what we've drawn using symmetry. Okay, very similar to what we did yesterday. You still got to plot some points. However, the symmetry will cut the work in half, and that's what we'll be working on next week. All right, have a great weekend, everyone.